Welcome back to another video and Happy New Year. My name is Derek and today I'm going to be taking a look at an iPad Air 5 that refuses to charge. So let's get into the video. Now I've already been working on this iPad Air 5 trying to see if I could troubleshoot why it's not charging. The charge port looked fine, but because at the time I really had no way of verifying that other than visually, I decided that I would go ahead and replace just the port itself, and that didn't seem to fix the issue. And one of the easiest ways to troubleshoot a issue with charging, especially on an Apple device, is to have a TriStar tester. That way you can simply plug it in and it'll tell you whether or not the port is good or the charging IC is good. However, the iPad Air 5 is not a Lightning port. It's a Type-C, which means that my TriStar tester won't work for it. And that's where this comes in. This is the iBridge A3. It has the ability to test Lightning ports and Type-C ports, and has the ability to give you accurate values for each one of the pins on either side of the port at the same time. Let's see if we can use this to help troubleshoot this iPad. And keep in mind, one of the main hurdles that I've run into is that although a board view is available for this, the data that needs to be imported that will be over time isn't available. So although I can see what connects to what, it doesn't really tell you anything as far as what components are or the values that you should be reading with a multimeter. And there's no schematic that I can find for the iPad Air 5. So I'm going to have to pull from basically all of my gained knowledge to see if we can troubleshoot this. Let's get started. All right, the iBridge 8. Let's take a look at it. Pop it open, slide it out. Let's change it to English. All right, got this nice toggle system. And then just to select something, you click into it. And this allows us to test the Lightning ports and also Type-Cs. Today we're going to be taking a look at this iPad Air 5. It's not charging. I've already somewhat disassembled it to look at the charge port. Let's test it real quick. And we get one negative thing on D-. I wonder what would happen if we flip this over. Given that this is my first time using this, let's see if it tests in reverse. Test. I wonder if this D- over here is going to pop up. Now we get an open line 0.088. So that D- didn't like it. This one's OL. It might supposed to be OL. Let's see. Go back to this side and see if they swap OL. Okay. Now, given the lack of information on the schematics, I can only start by trying a new charge port. I already replaced the port on the end of the flex, but it's a blind solder, so it might be best for me just to replace the entire flex just to ensure that we're good on the end. We'll take off the display and we'll take off the remaining screws and plates that are holding down the parts of the motherboard. We'll hold that down when it switches over to Lightning. Oh, that's really cool. So we'll be able to put power into this. All right, so on the back, we've got some little symbols here showing us where to go. And so if I hold this down, it'll switch over to the Lightning port, which is pretty cool. And if we keep holding that, it goes over to a supply monitor, which will allow us to connect power to it and see what it's drawing, which is really kind of cool. So this doubles or triples in a lot of ways the actions that something like a TriStar tester can do. So, and if I hold down the side button, it powers off. Cool. All right, we'll pop that off. Pop off this guy, disconnect all of the cables attached to the charge port, take out the screws that are holding the charge port in, and we'll lift that guy out gently. Now we can disconnect all of these coax connectors by just gently lifting up on the necks. Disconnect the camera, the microphone, and we'll disconnect these two coax connectors. Peel that away. Disconnect the front-facing camera and the little ZIF connector with its little sticker. It's quite the teardown, these little guys. Add some isopropyl alcohol to the flexes. I always hate these plastic ones. And then we can pop it out. There we go. And now we'll add some isopropyl alcohol along the motherboard. And let's slide in a spudger carefully. And it'll slowly lift away.
And this part of the board seems like it's ready to come out. I missed a coax connector here. Glad I saw that before I tore it off. And now the part where a lot of people struggle is this flex cable that goes across the top. We'll carefully get under this little daughter board extension and add some more isopropyl alcohol and slowly lift it away, just like that, and slowly peel away the last thing that's holding this board in. There we go. I want to see how this guy reads. Push that in, turn it on. Let's see how it reads when the motherboard is out. We'll slide it on in. It automatically runs the test for us. And we're back to not an OL on this side, which is good, but we do have that side that it still doesn't like. All right, so let's go under the microscope, replace the entire charge port flex. It might be that this is like an issue with the charging IC. Hopefully not, but if it is, we'll come to it at that point. All right, so we've got the back of the motherboard here. This is where the charge port's connected. Carefully peel away this sticker. We can reuse it if we're careful. If we mess it up, then we can just use some Kapton tape. Carefully peel it away. It'll want to roll up on itself once it comes off. I'm going to try to carefully unroll it. Okay. Now there's a bunch of different techniques to doing this next part, but here's one that I like to do. We'll add some flux. We'll take a generous amount of 138 solder paste. This is a low melting solder. And we will carefully melt it and apply it to the pads here. And this will kind of seep in and mix with the factory solder, making it much easier to extract. And we'll drag it along, letting it kind of pull up. What it will inevitably do is it'll pull up the solder from the logic board and replace it with the low melt. And I'll just continue to go around doing that. And you can see the black, almost oxidized layer that comes up with it in this particular solder paste. Now I'm going to take some wick and we're going to suck up as much of all of the solder as we can. Just like that, going back and forth, letting the wick suck up the solder. Take some isopropyl alcohol and a Q-tip and we'll clean up the flex, removing all of that burnt flux. And this may seem a little counterintuitive to bring it back to this state, but I found that it makes it so much easier to remove the flex here. So I'm just going to add a little bit more flux along it like that. I'm going to come in with some hot air now and we'll slowly warm it up, and what will happen is the solder will start to melt long before the board gets too hot to melt anything on the other side, and you can already see the flex wanting to start to come away in the bottom, giving it a little bit of upward tension, but not a lot, and it'll slowly start to pop away. There it comes, and just like that, we've removed it. Now let's take some time to just remove the old adhesive that's here on the bottom, and we'll also just clean up. We'll add some flux so we can wick away these pads. We want to remove all of the 138 solder. Get out our iron, and we'll really suck dry all of these solder pads here. Take some isopropyl alcohol and let's thoroughly clean the area, and we'll scrub off all of that old glue, just like that. Alright, so I've got here a charge port flex cable. This is a grade A OEM pull. The nice thing about this one is we've already got it kind of pre-tinned on the bottom side because it is an OEM pull. We'll add a little bit of flux on it, and then we'll add some flux to the top, and then we can line up the windows. If you haven't done a charge port before, that little square right here, there's another one on the other side, and there are two little windows where if you line them up perfectly, there's a little like black square within the window. If you line up the square within that little black square, everything will be lined up perfectly. So let's do that. One thing that can help as well is you put a teeny bit of flux on top of that square, and it creates kind of it helps the transparency pull through to the window just a little bit. On this side, what I'm going to do is I'm going to add a little bit of solder to the end, and then same on this one. This will help give something a little bit extra to grab onto when I tack both sides down. So we'll line up the window and tack it in place. And then we'll go over to the other side, and we should be able to pivot it just a little bit to find the square, just like that. Now I like the alignment, so I'm just going to go across the center and apply some solder to it. And now we'll compress the flex and solder on down each one of the pads. And we'll take our time to just slowly move across, covering about 6 pads at a time. Now this step may not be necessary, but I like to come in and reinforce whenever possible. So we're just going to add basically extra solder to all of the pads. Add some more flux to make these shinier and also allow the solder to flow a little bit cleaner. And the last step before testing is cleaning up all of the flux with some isopropyl alcohol. And let's go and test this out. Alright, so with our new charge port on there, let's go ahead and plug this in, turn it on, and let's run the test real quick. And we still have that one line reading off at 0.08, but everything else is good, which means I probably didn't need to replace this, but because the schematic doesn't really tell me what I need to be reading, it's kind of the first step. Alright, but I did remove the old one successfully, so it should still be, reusable if I really need to, so I'm not really down a part. Let's go take a look at the board view to see if we can track down anything, maybe the culprit, and we'll go from there. Alright, so let's take a look here, and I'm going to test each one. See, the values aren't given, but what I'm going to be looking for is on my multimeter values that kind of line up with what we were seeing on the iBridge tester. So got my red probe here on just a ground pin, and I'm going to go around the middle because that's where I'm guessing it's going to be. I think that's supposed to be ground. Let's just start on the edge here. 0.6, 0.6, 0.6, 0.6. Oh well, I don't think there's anything there. Anyway, 0.63, 0.24, 0.6. That says ground. 1, 2, 3, 4, 5, 6, 7, 8. Yep, that's supposed to be ground. And then these two aren't, so let's see. OL, ground, ground. High reading, 0.71, 0.71, 20, ground, OL, ground, OL. This is the last ground, yes. 0.6, OL, 15, 15, 15, 15, 15, 15, 15, 15. 0.6. These are all ground. Let's go over to this side. 0.6, 0.6, 29, 28, 6, 29, 28, 619. So the only thing that looks odd is got an open line there. Where was it? This guy right here. What is it supposed to be? This line is not liking it. Which he comes over here through this. Looks like a capacitor. Then a resistor. And goes to this charging IC. I believe this is a charging IC. The U12659. Let's see real quick what we're dealing with. Oh, and this is one of those I'm going to hide under the shield ones. So we do need to pop the shield off. So let's do that real fast. So what I'll do is we're going to take some heat to the shield here. The border of it does have a low melt around it that holds it down, or a lower melting. I'm going to try not to melt any of the plastic connectors I'm really close to. I'm just going to heat up the shield so we can pop it off. Alright, I started to melt the connector, so I'm going to back off of that area. So as I tear into this, it's following the edge where I created the score. Let's see what happens when I go past it. Kind of veers off. Alright, it ain't pretty, but we've exposed the component. And if you're curious as to which one we're talking about, it is this one right here, the CD3217B12. Alright, I've taken the time to really isolate the area with some Captain tape. That way I don't burn the connector anymore, or the two connectors right here off to the side. The dot is here at the top right corner. Our new USB and power delivery IC. You can see there's not a whole lot of clearance. It's basically touching this chip, almost touching these capacitors and this row of resistors. So it's really hard to misalign this one when putting it back. So Go ahead and turn on some hot air and let's get this guy off. We'll heat it up, gently tapping on the side without knocking into the capacitors. I want to see a little bit of movement, then I can lift it out. There it goes. Lift it up and out without knocking anything. While it's still a little warm, I'm going to take a teeny bit of 138 solder paste, get it down in there. We'll take our iron and with a little bit of flux, we're going to mix the solder paste with the factory solder all the way to each corner. We'll get out our wick and we'll suck up all of the solder off the board. Get that back into view. Okay, the hardest one to get is always this corner because it's right next to the shield there. Okay, take a Q-tip with some isopropyl alcohol and let's see if we can clean up all of the flux. There we go. We're going to add a little bit more flux, spread it around. Alright, we'll get out our new IC. One thing we can check as well before we put this on is that line that was giving us a weird reading with the multimeter. Alright, so here's that line. It's the number 1, 2, 3. So if we get out our multimeter, go into continuity and diode mode, red on ground, we now have an OL there. Well, time to solder it back on. As you can see, it's been pre-balled for us. We'll line it on up with the dot in the top right corner. Alright, we'll tap the chip into place. That's about where it was. We'll come in with the hot air and snap it into place. I don't like what the flux is doing. It's sucking to the other chip. Or leave that surface tension, so I'm going to remove the flux it's kissed up against that as best as I can. Okay, let's try this again. Let's line it up. There, I like that now. So let's heat it up. There's some movement in it. There's a snap. Let's give it a little nudge. I like it. We'll pull the heat away and let it cool down, and then we can test it. Alright, let's take a look and see what we get now when we plug this in. Alright, test. And look at that. Everything is green, which means it's a good chance that this is fixed and is going to charge again. So let's go ahead and reassemble this and test it. For now, we'll isolate the battery connector and we'll carefully remove the Kapton tape. All right, and to not forget as well, you can use some Kapton tape if you haven't been able to salvage the little black sticker here. As long as I can peel it back up, we'll just reuse it. All right, so we'll lay it on down and cover up all of the joints. We'll carefully put everything back. Actually, I'm pretty confident right now. So we'll go ahead and peel off this because it'll be near impossible to get to it later. We'll slide in the charge port. All right, so I'll go ahead and now that we've got the board kind of installed, go ahead and start connecting everything back up. Each one of the little ZIF connectors and FVC connectors. All right, everything is connected up there. Put back the shield and the screw, and same goes for this one, just like that. Now, I won't worry about connecting any of this stuff down here just yet. First, let's get the display reconnected. All right, the display is now connected. We can now slide out the plastic that was protecting the battery. It's stuck to the charge port. Let's get that off. Okay, we'll screw down the battery screw. And a moment of truth. All right, let's plug it in. I see a flash. Oh, there we go. There's the Apple. That's the battery logo. Let's look at that again. Okay, and the battery is just really dead. So let's let this charge up a little bit and see if it comes on and charges. Touch the power button real quick and just see if that logo comes back. And look at that. Yep. So we should be fixed. I'm actually curious to see when I unplug it. Let's plug in the tester. Everything still runs green. All right, so we can see that it's charging. All right, so we are on and we are charging. That is wonderful. Let's flip this around. Oh my gosh, the messages that are coming through. Let's flip it around and look, we're charging 1%. Just barely turned on. A little bit more work to get this back up and fully running. We need to put back the shield, the brackets and screws, reconnect everything down here. But yeah, this iPad is fixed.
A few minutes later.
And we are at 2%. So that's just one thing I always like to check is to make sure it goes above 1%. Because sometimes if it can't pass 1%, that's indicative of another issue. So this iPad is basically done.
And there you go. You can see that it's all charging once again. And I'm glad that I was able to show you my process by simply replacing the components that are somewhat easy to replace, like the charge port and then troubleshooting from there. Hopefully soon there will be more data on the schematic and board view side of things to make this easier in the future. If you found this video useful, like and subscribe. Thanks a ton for watching, and we'll see you in the next video.